Before we continue with further topics on distributions, we will do some exercises. So, first one, let T belong to D prime of R and phi belong to D of R. Does either of the following statements imply the other? A, T of phi equal to 0, B, phi T equal to 0. So, we have two statements and we want to know if A implies B or B implies A. Now, what do we guess from this? First one is a very weak statement, it just says T of phi equal to 0. You cannot expect really that it should have widespread repercussions. Whereas phi of t equals 0 is a statement which refers to all C infinity functions, because phi of t equal to 0 means phi of t of phi 1 equal to 0 for every phi 1 in DFR. So, you can expect B to be a stronger statement, and therefore, we do not really expect A to imply B, but B might imply A, we have to check that. Okay, so let us first see the following. So, we will give an example. So, let T equal to D delta dash and let phi in DFR such that phi 0 equals 1 and phi dash 0 is 0. Okay. So, then what is T of phi? T of phi is delta dash phi equal to minus delta of phi dash. So, this is minus phi dash of 0 and that is given to be 0. Whereas, what is phi t? Phi t of psi is equal to T of phi psi, which is equal to delta dash of phi psi, which is equal to minus delta of phi psi dash, which is phi dash psi plus psi dash phi, which is equal to phi dash 0, which is 0 at psi of 0, and minus psi dash 0 phi of 0, which is 1, which is equal to minus psi dash 0, which is equal to delta dash psi. Okay. So, therefore, this is not equal to 0. So, which is not 0. Therefore, you have that A does not imply B, as is to be expected. Okay. Now, let us assume B true. Therefore, you have phi t is equal to 0. What does it mean? This means that for every psi in D of R, you have phi of t psi equal to T of phi psi, and that is equal to 0. So, we want to know in particular this T of phi itself 0. Okay, so let us take K equal to support of phi compact, and let us take psi to be identically 1 in a neighborhood of K and psi in D of R. So, we know that such cutoff functions exist, and therefore, you have then what do you have? 1 minus psi into phi. Now, psi is identically 1 in the neighborhood of the support of phi. So, this is 0 in the neighborhood of support of phi, this is 0 outside the support of psi. So, this is identically 0. So, T of phi minus psi phi equal to 0. So, T of phi equals T of phi psi, but T of phi psi is 0 because that is given, and therefore, T of phi equal to 0. So, B implies A. Okay, so that is the exercise. Second one, let t belong to d dash of r such that x square t is equal to 0, then show that there exists C naught C1 in R such that t equal to C naught delta plus C1 delta dash. So, this means that if you have support x square t equal to 0, then t must be a combination of Dirac and its first derivative only. So, solution. So, let phi in d of r and support of phi contained in r minus 0. So, we are what do we expect? At 0 x is 0, outside 0 x is not 0, and we expect t to be 0. Roughly if these were functions, that is what would happen, and that is what we are trying to show also for the distribution. So, we want to show that the support of t is at the origin, in which case t will be a linear combination of Dirac and its derivatives. So, we are first going to show that the support of phi is that. So, for that we look at phi, support of phi contained in r minus 0. Then you take psi of x. So, psi of x equal to phi of x by x square. Now, this belongs to d of r again, because this has support away from the origin. Therefore, when you divide by x square, it is perfectly well defined. At the origin, near the origin, the function is 0, and therefore division by 0 does not matter. Okay. So, this is a function which is well defined and it is in d of r. Therefore, you can have, but x square t equal to 0. So, x square t acting on psi equal to 0, this is equal to t of x square psi, and that is equal to x square psi is nothing but t of phi. So, t of phi is 0 for all phi such that support of phi is away from this. So, what does this imply? T vanishes on r minus 0. So, that is the largest possible open set you can have, and therefore, support of t is the singleton origin. So, this implies that there exists a k and C alpha Ci 0 less than equal to I less than equal to k, such that we have proved this t is equal to sigma I equal to 0 to k of Ci di delta. Okay, so this is what we have, and then but we also have that x square t equals 0. So, let us take di delta I greater or equal to 2 x square phi. So, x square t equal to 0 means what? T acting on x square phi is always 0. Okay. So, di delta of x square phi equal to minus 1 to the I of delta acting on. So, okay. So, I have used some different notation. So, let us say delta acting on di of x square phi. Now, you apply Leibniz formula. So, this is equal to minus 1 power I into delta acting on what? Di of x square phi is x square times the ith derivative of phi plus IC1 into 2x phi I to the I minus 1 plus IC2 into 2 phi to the I minus 2, and thereafter there will not be any more derivatives because x square will not have any more derivatives after that. Okay. So, if I is bigger than 2, this is what we have, and therefore, this is equal to minus 1 power I. These two vanish at x equal to 0. So, 2 times IC2 times phi of I minus 2 0. Okay. So, choose phi in D of R such that phi of I minus 2 0 is equal to 1, all other derivatives up to k equal to 0. We can always do that, and this will imply if you apply it to t, so t of x square t of phi equal to 0, and this will imply that Ci equal to 0. Therefore, so this implies that Ci equal to 0 for all I greater than or equal to 2, and therefore t is equal to C naught delta plus C1 times delta 1. Okay, or delta dash. So, you just plug it in and you check that fact. Okay. 3. Let phi belong to D of R2. Define T of phi equals integral over R phi of x comma minus x dx. 1. Show that T belongs to D prime of R2, that it is a distribution. What is the order of T? Three. What is the support of T? And 4. Compute dt by dx minus dt by dy. So, solution. So, let us take support of A of phi to be contained in some big box. So, minus a whole square, okay, mod, and let us say mod phi is less than or equal to m. Okay. Then what is mod of T phi? This is less than or equal to integral minus a to a mod phi of x comma minus x dx, okay, and that is equal to m times 2a, okay, which is 2a times norm phi 0. So, this implies that T defines the distribution and order of T equal to 0, because you have such an inequality. Remember, we proved a theorem for every phi, if you can prove such a thing with a constant depending on the support of phi, which here it is 2a, and therefore here you have an independent of the support, this for all C infinity functions with compact support, and therefore the order of T is 0. Okay, so that solves 1 and 2. What about the support of T? So, 3. So, let us take support of phi. So, let support of phi contained in R2 minus set of all x y in R2 such that x plus y equal to 0. Okay. So, then this implies that phi of x comma minus x equal to 0, and therefore implies T phi equal to 0. Therefore, support of phi is contained in the set of all x y in R2 such that x plus y equal to 0. But if you take the line y equal to minus x, you can always find a function which is supported in any part of that line. So, and therefore so the integral will not be equal to 0. So, in fact, you can say that support phi is equal to set of all x y such that x plus y equal to 0. So, now let us compute the derivative. So, what is dt by dx? minus dt by dy acting on phi. This is equal to minus t acting on d phi by dx minus d phi by dy, which is equal to t acting on phi y minus phi x. That is phi y is d phi by dy, and so I am just writing phi y equals d phi by dy and phi x equals d phi by dx. I am just using that notation. Okay. So, and what is that equal to? That is equal to integral over r of d phi by dy at x minus x minus d phi by dx at x minus x. So, now let us define psi of x is equal to phi of x minus x. So, then what is d psi by dx? This is equal to phi x at x minus x minus phi y at x minus x. Okay, and that is, so this is equal to minus of integral over r d psi by dx times dx. But phi has compact support, this is equal to 0 since phi and hence psi has compact support. So, this implies, so this is true for every phi. So, dt by dx minus dt by dy equal to 0. Four. Compute limit epsilon going to 0, epsilon by x square plus epsilon square in d prime r. So, solution. So, let phi belong to d prime of r. So, we have to look at epsilon integral over r phi x dx by x square plus epsilon square. So, we want to look at the limit as epsilon goes to 0 of this. Okay. So, epsilon integral over r phi x by x square plus epsilon square dx. I will pull out the epsilon in the denominator. So, epsilon square. So, that will give you 1 by epsilon integral phi of x by epsilon, sorry, that is just phi x, nothing happens there, by 1 plus x square by epsilon square dx. So, you have x by epsilon equal to y. So, dx will be, dx by epsilon will be dy. So, this is equal to, so integral over r. So, integral over r again. But now integral over r I can write as integral minus a to a, where support of phi is contained in minus a to a. Okay, I won't do that. So, this will be integral over r again. So, phi of epsilon y divided by 1 plus y square, and dx by epsilon is dy. So, that will just give you that. Okay, so I am going to write this as integral over r phi of epsilon y minus phi 0 by 1 plus y square dy plus phi 0 into integral dy by 1 plus y square over r. Okay. So, f of y equal to 1 by 1 plus y square is integrable. So, you can check that. So, away from the origin, This is near the origin, this is a nice continuous function, it does not vanish, and in the neighborhood of the origin, and away from the origin it is less than or equal to 1 by y square, and which is an integrable function. Okay, and therefore you have that f of y is integrable. Okay, so then, and also you can compute the integral dy by 1 plus y square over r. So this is equal to twice integral 0 to infinity dy by 1 plus y square, which is tan inverse of y. So 2 tan inverse of y 0 to infinity, and that is equal to pi. Okay, fine. So now phi epsilon y minus phi 0 by 1 plus y square, this converges to 0 pointwise, and mod of phi epsilon y minus phi of 0 by 1 plus y square is less than or equal to 2 times norm phi infinity times 1 by 1 plus y square, and that is integrable. Therefore, by the dominated convergence theorem, we get that the limit, we know what the limit is. So, we have limit epsilon tending to 0 equals, so the first term goes to 0 by the dominated convergence theorem, and the second one we just now computed, that is equal to pi times phi of 0, which is equal to pi delta times phi. Okay. Therefore, limit of epsilon going to 0 of epsilon by x square plus epsilon square equal to pi delta in d prime omega r. Okay. 5. Okay. We have already used this, and I said it is very easy. So, let us do this. When we discussed compact distributions with compact support. Okay. So, let show that d of Rn is densely included in E of Rn. This is A, and B, if psi belongs to E of Rn, psi greater than or equal to 0, show that there exists phi n in D of Rn, phi n greater than or equal to 0, and phi n tending to psi in E of Rn. So, you can approximate any non-negative C infinity function by a non-negative C infinity function with compact support. Okay. So, this non-negativity can be preserved. So, solution. So, again very easy. So, A. So, let us take phi n, let phi n belong to D of Rn such that 1, 0 less than or equal to phi n less than or equal to 1, 2, phi n is identically 1 in a neighborhood of the closed ball center origin and say radius n, and 3, support of phi n is contained in some other, so let us say B closure 0, let us say n plus 1, you can put anything bigger than n here, it does not matter what you are going to put here. Okay, so this is given. So now let us take psi in E of Rn and consider psi n of phi n times psi. This is a product of a distribution with compact support and C infinity function with compact support and a C infinity function. So then this belongs to D of Rn. In fact, support of phi n psi should be contained in the support of phi n, and that is contained in B closure 0 n. Okay, so that is compact. Okay. So, now let K be any compact set. Then for n, so there exists n naught such that for n greater or equal to n naught, we have K is contained in the ball center origin radius n. After some time you can absorb it in any big ball, okay. So, since it is a compact set, okay. So, compact sets are bounded and therefore, you can put them inside any big ball after some time. So, on K, we have that psi n is identically 1. So, psi n phi n is identically 1 equal to psi. So, trivially these functions agree on terminally on any compact set. So, this implies that phi n psi converges. So, all there is no convergence, it is just equal, and therefore, in E of Rn, and therefore, you have approximated everything. Now, if psi is greater than or equal to 0, clearly phi n psi is greater than or equal to 0. Okay, so that completes. Okay, so we will stop with this, and now we will continue with some further topics in the theory of distributions next time.